Welcome to the Autonomic Homeostasis Activation podcast. I'm Pals.
And I'm Ruth Lorensson. We'll be unpacking what it looks like to activate your brain to holistically manage stress and trauma to facilitate homeostasis.
Being free to experience wellness in body, mind, and spirit.
Thank you for joining us. Let's get this conversation started. Well, hello, Tom.
Hi, Ruth.
We're here for another conversation.
Oh, yeah, and I'm excited.
You are really excited this morning, and I've come in and we've had a chat, and you're super excited because this is what we're going to talk about, right?
Yeah.
There's a kind of a new development in terms of what you've been pursuing for such a long time now, AHA, Autonomic Homeostasis Activation, and just we've often talked about your journey discovering AHA as a jigsaw puzzle. It was like, over the years, and, it's been a long time. There's just been like a piece of the puzzle that you've received, and that has created this whole picture of AHA. And so I think, is it fair to describe, there's this you've got most of it there, but there's this one little piece that actually is super significant. And it's all about the brain, which is where we're in right now. We're trying to unpack the brain in the series of the AHA podcast. So kick us off, because I don't think I can do it justice. How did what's been going on?
Yeah. So I have been practically experiencing with people, particularly when it's not just the somatic homeostasis, AHA, but the cognitive homeostasis. And so with the AHA problem solving, the brain itself is solving problems that the person with their mind just couldn't figure out. And there's an episode or two on AHA problem solving and an example of the involuntary autobiographical cognition that's occurring, the learning, the problem solving, the remembering information, but applying it in new ways and anticipation and all of that. And I've been experiencing that hundreds and hundreds and hundreds and hundreds of times in sessions with people in the wellness coaching, because I'm clearly not doing that. The brain is doing all the thinking. I'm just coaching the person in how to listen to their brain speaking. Okay. And one of the critical missing pieces from the neuroscience perspective was that I've never seen, nor had there ever been any neuroscience research demonstrating what I was practically experiencing with people as their brain was engaging in that. Okay. And it's been done. That's why I'm so incredibly excited, because this is just last June 28th, 2026. It was published in the Science News and the study was brain activity under anesthesia challenges what we know about consciousness. So consciousness, let me unpack this that way, okay? So consciousness is just interoception, sensory awareness of, I sense that I am consciousness, and your pet is conscious, you are conscious, but that's always been thought of as different than cognition. Cognition is thinking, processing information. So an amoeba or a cell or some little thing, like when I'm with my granddaughter and we're walking and there's a pill bug and it's kind of scooting along the sidewalk and we put our finger near it, not touching it because we want to respect that and not frighten it, but put something near it, and it curls up in a little ball
Hmm.
protectively. It's conscious. It is sentient. It is aware of its surroundings, that sort of thing. Now, the degree of cognition, hopefully we have a bit more ability to process information than a pill bug. Who knows? But anyway, so we're at least able to express that more than just curling up in a little ball. But if you think about it, when we are in an extreme trauma situation, we might do the same thing, and it's called the fetal position, and I'm just all curled up like that little pill bug. My point is that what has always been this dividing line and this mystery is, to what degree does our own brain itself, as opposed to us with our mind, process information, learn, memorize, anticipate? That's always been associated with the prefrontal cortex. So back to the baseball mitt and the ball in the mitt.
So we're talking about, just in case a listener's just popped
Okay.
on and not listened to anything else, in one of the first episodes of this season, which is about the brain, so probably like 6 or 7 episodes ago, we started with just really describing how the brain fits together, and you had like an analogy of the baseball mitt and the ball in the middle. Is super helpful if you want to. It just helps you remember how to see the brain, really. I think.
So the baseball mitt, think of your hand on top of your head, but the part of the brain inside below the skull, like a baseball mitt, is the cortex. It's cortical. Okay. And the baseball that's in the mitt is the limbic system. And that's subcortical. It's the ball in under the cortex.
Yeah.
So my sense of AHA has been that it is subcortical. It's very much about the limbic system, the hippocampus, the hypothalamus, and relaying information back and forth between, and go back and listen to a prior episode where I talked about how the I'm losing so many thoughts going on right now. Anyway, the amygdala is often primarily associated with flight or fight, and it communicates with the sympathetic, but it's both parasympathetic and sympathetic. It just depends on what it's being asked to do. So in the limbic system, there is the amygdala, which is about motivation and reinforcement of, oh, I really like this. This is great. And reinforcement, or, oh no, yikes. And sympathetic or parasympathetic. And the hippocampus, those hippos at that university, memorizing information and learning. And then the hypothalamus is like that. It's not just the thermostat for the body. That's a function, but it's more like if there was a command center for the entire home, not just the thermostat, but all the wiring, all of the appliances, everything, and we're moving in the direction of having something like that. It's that.
Yeah.
But
so
think of it as, yes.
So the hypothalamus is a whole system regulation for homeostasis.
Exactly. Okay. So this is all subcortical.
Okay.
And that's what we see during AHA sessions. And when the AHA problem solving, we prompt the brain we activate, have that interoception activation from the enteric nervous system, the part of the brain down in the gut. And then we prompt the brain with a stimulus question, and then it just starts thinking, and we hear thoughts.
So let's just go back, which is amazing, I want to say, because I'm moving on, but I'm just used to it because I've seen so many, I've had my own experiences with that. But so let's talk about this research then, because it's this research that you haven't been able to do this research, but, this university
Baylor College of Medicine.
They've been able to do this research, which obviously isn't trying to do research for AHA, but it's addressing the same issue that you would have addressed in research, so or would have looked for. So it's looking for the same thing that you would have loved to look for if if we, in an ideal world, and if there's anyone out there, just to be able to do some research with AHA would be a dream, and we will see. We'll see what the future holds in that. But Baylor University has done this research that really is kind of addressing the same dynamic that you have seen in AHA. So talk more about that bit.
Yeah. So brain activity under anesthesia challenges what we know about consciousness. That's why I was distinguishing consciousness from cognition as well. So this just came out June 28, 2026. The unconscious brain appears to be, and I'm reading from the summary, appears to be far more capable than scientists have believed. Researchers found that patients under general anesthesia could still process language at a sophisticated level, distinguishing nouns, verbs, and adjectives while listening to stories. The person's conscious is unconscious. But the brain was still doing that. Even more remarkably, neural activity showed signs of predicting upcoming words before they were heard. So, like when you're texting on your mobile device or you're writing and your device is suggesting a next word to insert there.
Yeah.
That's the artificial intelligence machine learning version of what the human brain itself does. Have you ever experienced jinx?
Double jinx.
Double jinx, yes. And that is where two brains are processing the information together and say the same thing at the same time. It's that happening mutually. You follow that?
Yeah. So with the research, they were able to see what was happening when the person is unconscious and the brain is not only active, but it's learning.
Yep. So they recorded the activity of hundreds of individual neurons. And remember what I've said about neurons. They have nannies. And the glial cells are what make it possible for the neurons to process information. And there's some other really recent information that showed that it's not just the neurons that process information. The glial cells process information too. Neurons do it electrically. Glial cells do it chemically. But they're still both processing information. Again, it's neuron-centric. No, it's both the glial cells and the neurons. The neurons can't even survive or function without the glial cell making it possible for them to do that. I'm getting off. But anyway, so they recorded the activity of hundreds of individual neurons in the hippocampus, subcortical, not cortex processing information, us thinking, that sort of thing. The person's under anesthesia, they're out. The cortex
and the hippocampus is the place of memory
and learning.
Yeah. Okay.
the university that is the repository and the place of understanding and learning, and my way of helping people remember the hippocampus is that all the students on the campus are hippos and they're there to memorize information and learn. And so the recordings were made while patients were under general anesthesia. So what they did was, the first experiment, there were just sounds repeating sequentially with random interruptions of other sounds. Okay. And the brain was seen to be learning about the interruptions and even anticipating when it might occur from the regulated pattern. Then they went further and they increased the complexity of the experiment by playing short stories. Remember, the person is not conscious.
Mm-hmm.
They're under anesthesia. They're out. They played short stories while continuing to record brain activity. And the hippocampus showed clear evidence of processing language in real time. Patterns of neural activity revealed that the brain could distinguish different parts of speech, nouns, verbs, and adjectives. And then another part of the surprise was that it could predict upcoming words
Just like
before they were spoken.
Yeah. Wow. Mm-hmm.
Yeah. So, to quote Sheth, the brain appears to anticipate what comes next in a story, even without conscious awareness. Even without conscious awareness. This kind of predictive coding is something we associate with being awake and attentive. Yet it's happening here in an unconscious state. This is why, this is another really critical piece in the jigsaw puzzle of AHA. I'd seen the brain doing this. I just I didn't have what I needed to do this kind of neuroscience experimentation. But from a practical perspective, this is what we experience in AHA problem solving. We just don't have to be as anesthetized to start with. And two, we can hear it.
And I think this is key, because it's actually, interestingly enough, I think the brain is always, the reality is the brain is always thinking, whether we are conscious or unconscious.
Yes.
But it's whether we hear it or what we attribute those thoughts to being. So, and I think the thing that AHA does is that what we see is that there's this ability for us to actually engage and go, oh, this is the brain.
Yep.
And actually, we talked about this before, Tom, just even for me, in my life, I've heard the brain, like that inner voice, that's slightly different from another voice. And some people can attribute it to all sorts of things, but it is those autobiographical cognitions that come up. It's that little voice that says, oh no, you're okay, Ruth. And suddenly it's like, why are you calling me Ruth when I'm Ruth? And it's just like a different way, a different voice, but it feels very familiar.
Yes.
And I think that what we're suggesting here is that what this research is saying is that this is proving that is actually happening. The mind of consciousness is quietened, and we're seeing the brain is thinking.
Yes.
In AHA, the remarkable thing is that we can do this in real life. Like we can, activate the brain, have that interoceptive engagement, ask the brain a question and actually tune in and hear what it has to say, which is amazing. But before we go on, talk about the hypothalamus, because that came up in that research too. And, we haven't talked about the hypothalamus that much in terms of the brain. And what is the hypothalamus and what role does it have to play? And what did that research have to say?
It's tangential to the research. The research was all about the hippocampus.
Okay. Mm-hmm.
But the hippocampus and the hypothalamus have a dynamic relationship. So think of the hippocampus as memory and learning, even spatial navigation. Why would that be related to memory and learning? Because you have learned that if there is a solid object in front of you, you step around it. You've learned that.
Mm-hmm.
And your brain remembers that. And so when you're spatially navigating, that's involved in the hippocampus. One of the things that I'm doing and learning is scuba diving. I love scuba diving. Jacques Cousteau had a famous quote that, and let me back up. So I love climbing the 14ers here in Colorado. And the higher you go, the less oxygen there is. And if you go high enough, there is no oxygen. Well, if you think about it, all that gravity that's pulling on you that makes climbing to the tops and the summits, you're encountering that and dealing with that.
Mm-hmm.
But the opposite is also the case. And I've gone a couple of times scuba diving in the Gulf of Thailand and the Gulf of the Sea of Cortez, and more recently in the other side, the Pacific side, and the Atlantic. So I've scuba dived in various places, and one of the things that I absolutely adore about scuba diving is when you sink beneath the surface, and it's that weightlessness. Because you're carrying the oxygen with you in the scuba tank. So Jacques Cousteau famously said, when you sink beneath the waves, when you sink beneath the surface, you find that you are free. Free of the gravity, free of all of that. And it's just this incredible immersion in an entirely different ecosystem. And it's just absolutely wonderful. My point is that the brain is processing where I am and what I'm doing. The hypothalamus is helping to regulate breathe or slow down or you see what I mean?
Mm-hmm.
My point is that the hypothalamus is very much about regulating my experience of that. The hippocampus is all about the information related to the memory, the learning, that sort of thing. So you can't have one without the other. If you don't have the information in your hippocampus, you're going to walk into a wall.
Mm-hmm.
But what do you do with approaching it and navigating it? That's the hippocampus.
Mm-hmm.
But then the hypothalamus is about regulating the whole system of you moving to start with.
Yeah.
Does that make sense?
Yeah.
And so what the hypothalamus function is it's the control center.
Mm-hmm.
It maintains homeostasis by connecting the nervous system to everything, particularly the endocrine system, the pituitary gland, et cetera, hormone production, the autonomic regulation, drives of hunger, thirst, arousal. It's all of that that so much of is what we would think of, I'm alive.
Yeah.
And I'm not just surviving, but I'm thriving.
Mm-hmm.
And that's the hypothalamus. Even sleep-wake cycles, it's regulating that. That's the hypothalamus. But it does that in concert with the hippocampus.
Mm-hmm.
What we've learned, what we've memorized, that sort of thing. And why this is so significant is because of the impact of trauma, not just on the hippocampus, okay, but also on the hypothalamus. It's regulating sleep-wake. How much is that involved in trauma?
Mm-hmm. Yeah. So what you're saying is that when we have trauma in our lives, whatever that might be for us, it has an impact on the hypothalamus and the hippocampus. So our environment is, and we researched this, I was telling you earlier, even women in menopause, it has, the drop in estrogen has an impact on the hypothalamus. And so in an ideal world, these things, those two would be working perfectly together, and we'd be able to hear the brain think more, and everything, homeostasis in our somatically and even in our problem solving would be optimal. But we're not in that perfect world. We're in a world that's full of stress and trauma, and actually those stresses, those traumas impact those areas. And so when we come into an AHA session and
the somatic,
and the problem solving, what
cognitive.
we end up doing is allowing the brain to take over, and they end up relating optimally again, which is what they were supposed to do in a world that wasn't so chaotic and complex. And that's where the restoration comes from, or the wisdom in terms of the problem solving.
Absolutely. This research really demonstrates the capacity of the brain, not just to process information, but to think, to engage in cognition on its own, to learn, to anticipate. The invitation then is, and building on what was in the last podcast, to let that inform our relationship with our own brain. Think of it this way. Your brain as another person, another entity. Does that make sense?
Mm-hmm.
And if you are constantly questioning that other person, constantly assuming malicious intentions, what's that relationship going to be like? Mm-hmm. Or untrustworthy. How is that going to affect?
Or ignoring
it, blissfully unaware of you, and I don't care about you, as opposed to deeply invested in you not just surviving, but thriving. And have a relationship with your own brain based on that. Because here's the thing. As it is thinking, as it is processing information, as it is anticipating, it's doing that in response to you thinking.
Yeah.
Think about that for just a minute. All the thinking that you're doing, your brain is hearing. Like in that study where the person was under anesthesia and unconscious, the brain was hearing these short stories. The reality is, we're always telling stories to our brain. And frequently it's just trying to make sense of the nonsense of our stories and anticipate where this is going, knowing that if it goes that direction, that's not a good thing, but I got to account for your storytelling. So my point is, we know now that the brain thinks. Give it something to think about that is allied with its fundamental purpose of wellness and thriving.
And I, as you're talking there, I just have this picture come to mind of, like if, I don't know, I'm just thinking about people who would be like camping in the wilderness or something. And, maybe there's a group and there's one of them sleeps and the other one sits up all night to watch for wild animals or anything like that. And I see the brain, that's kind of, it's like the brain is that person. And, normally in human life, you have to like switch roles and because someone needs sleep. But actually, it's this amazing person that is with us in life that when we sleep, it never switches off. It's constantly thinking, it's constantly processing, it's constantly protecting. Its job is for our well-being. I mean, that's an incredibly endearing picture that even when we're asleep, we're protected by our own brains.
When we're not conscious,
it is. Yeah.
When we are not conscious.
We just did a jinx thing.
We did. The brain is conscious.
And I think that is, it's a much deeper understanding of our existence, isn't it? Yeah. And it really is that we're not just, I think, we're not just individuals. We are that. We've talked about this before. Me-wees. We are we're us individually, and we have our minds and there's some
personalities.
Yeah, all of that stuff. But then we're also a collective, and we're living this life, even in our own human bodies, collectively.
Yes.
Especially, and our brain is an incredibly important part of that, an incredibly life-giving, wise part of our lives. So to be able to engage with it, to listen to it, to even understand that is a gift, I think. Yeah. So I'm excited with you, Tom. Like, this is cool, and just hopefully just really helpful for our listeners too to understand. We're talking about these some big topics on neuroscience, and yet, I mean, the purpose is well-being, wellness, and so we're hoping that these conversations are accessible so that we can do that, live well.
Yes, as I have been saying for years, the brain has a mind of its own, and it is wise.
You've been listening to the Autonomic Homeostasis Activation podcast. Join us next time as we continue in our conversations with Tom.
If you're interested in pursuing your own wellness journey, please check out our website, autonomichealing.org.
You can also reach out to Tom at innerworkings.org.